Okay, today we are going to do 824, completing the quadratic web. You know how to make a table for a quadratic rule, but how could you write an equation when given a table? Examine the new connection that requires you to reverse your understanding of the zero product property as you find a rule for each table below. What clues in the table help you find the rule? How can you check your equation using a graphing calculator? So on this, what you can do is you know that the x-intercepts are the roots. And so since this x-intercept is -3, that means I know I would plug in a -3 here. And so remember, you kind of have to think backwards. It's like, what equation would you solve for the answer to be -3? So it'd be x plus 3. Then you go over here and you'll see the next one is at 2, 0. So then what equation would you have to solve for your answer to be 2? And that'd be x minus 2. From there, you can go through and you can either do the generic rectangle to multiply. I just did the distributive property real quick. So x times x, 3 times x, x times -2, 3 times -2. And then you can combine these like terms because they both have an x. And so this equation would be x squared plus x minus 6. And so if you have a table where you know the x-intercepts, then boom, you can find the equation for your parabola. Let's do it again down here. Here's an x-intercept at -5, 0, and here's one at 1, 0. So think about what equation you'd have to solve for your answer to be -5. That'd be x plus 5. And this one would be x minus 0. So then again, I did the distributive property x times x, 5 times x, x times -1, 5 times -1. You can combine 5x minus x and get 4x. So that one, you know your equation is x squared plus 4x minus 5 equals y. So it's all about looking at those x-intercepts. So again, up here, the questions, what clues in the table help you find your rule? The x-intercepts. And how can you check your equation using your graphing calculator? You can type it in at Desmos, and you can type this into Desmos, and then you can check to see that your points all work. On the back, you are quality control. And so congratulations with your promotion. You're now the quality assurance representative of the Function Factory. Your job is to make your clients happy. Whenever a client writes to the company, you must reply with clear directions that will help solve the problem. Your boss has provided graphing technology and a team of fellow employees to help you fulfill your job description. 1, you're going to carefully read the complaints below, and then we're going to solve each situation. 2, write each customer a friendly response that offers a solution to his or her problem. We're not going to necessarily write this as a friendly response. We're just going to talk about what the problems were. So, dear Miss Quadratic, I followed all the directions given in your brochure about how to order a parabola. I tried to order a parabola that passed through the points 1, 0 and -6, 0, only to have you send me the wrong one. Please tell me how to order the correct parabola. Your immediate reply is appreciated. Well, if you want the points 1, 0 and -6, 0, you're going to want to order that parabola. Again, think about what equation you'd have to solve to get the answer of 1, what equation you have to solve to get the answer of -6. So they would want to order that one. B, I am a very dissatisfied customer. I wanted a parabola that hits the x-axis only once at 5, 0. Yet I see no mention of this type of parabola in your pamphlet. Your company mission statement assures me that my needs will be met no matter what. How should I order my special parabola? Well, if it only is going to have one x-intercept, what that's going to mean is that it's going to be that squared. And so think about what equation you have to solve for 5 to be the answer, and it'd be x minus 5. But since it's a parabola, you have to have 2 because you're factoring these trinomials. And so it'd have to be the same thing. So it'd be x minus 5 times x minus 5. That way it's only landing at the x-intercept one time. And number 3, please help. I have searched through your entire brochure, did not see parabolas that would fit my needs. All I want is a parabola that looks like this one. Every time I order an equation, To give me this parabola, you always send me a different one. I refuse to pay for any parabola but the one shown above. Please tell me how I should find this equation of a parabola, or I will take my business elsewhere. Well, if you look at the x-intercepts, this one's at -3, this one's at 2. So you would have to solve these problems of x minus 2 and x plus 3. But the problem is, this one is a sad parabola, so it's going to be negative, and so you need to put a negative on the outside, and I bet that that's what that dissatisfied customer is not doing. Stay tuned for video 2 for the rest.